So hello everyone, we are moving towards the next subtopic, which is the pipette tip microSPE as well as in syringe microSPE. So from the name itself, it denotes something that is inside a tip. Okay, so here, so this is your normal micropipette tip, okay, the 1000 microliter size, and you can see that inside this tip we have the sorbent. Okay, just imagine the SPE sorbent that we learned before, the conventional SPE sorbent. So we take it out from the SPE sorbent and put it inside pipette tip, and then we put a frit so that it won't come out or go out. Okay, so why this method comes in? Why is this developed by scientists? Because we want to increase the efficiency of the technique itself. So imagine if you have hundreds of thousands of samples, can you afford the conventional SPE? Not much, right? But if you can modify your own micropipette tips, whereby you just take the micropipette to draw volume, to draw liquid according to volume, and then in the same time you also do the extraction. So that's the idea behind this technique. Okay, so if you see from here, this diagram, we still have the CLWE principle, the conditioning, loading, washing, and elution. So on the first one, how do we condition the sorbent inside the pipette? So just use the micro pipette over here. You draw liquid up, okay, and then you already condition your sorbent already. So which solvent to use during condition is the same with the SPE that we discussed before. So and then you load your sample. In this case, we don't load from upper side. We load it by vacuuming in the solution of sample inside the sorbent. This is called aspirating the sample. And then if we stop over here, because there is a frit, so we don't have to worry. There is a frit over here, and then we aspirate, and then we suck in air. Okay, why do we suck in air? Because we want the sorbent to be like mixing around with the sample, just like how we vortex the mixture. Okay, and then what do we do? After we mix everything, we discharge the sample out. Okay, just like the SPE, the solution must be out, right? Leaving behind only the analyte adsorbed on the sorbent. Next, we wash the sorbent with water or solvent that will not elute the analyte. Wash by withdrawing in and then out, and then we draw in the elution solvent, methanol, ethanol, acetate, anything, up and down, just like how we do in mixing over here, and then we get the extract already. So this extract is microliter size, okay, and then you can direct go to the GC or HPLC. So this pipette tip microSPE examples is determination of methamphetamine and amphetamine in human whole blood using C18 monotip. So C18 stands for the silica C18 sorbent, just like the SPE, means that the desorption mechanism is there. Okay, so based on the polarity, remember, I hope you still remember. So this is commercially available, and you see that the extraction is happening here. As compared from blank and blood extract, we can see better peaks. Okay, because any solid phase extraction method means that we want to pre-concentrate the analyte. Means that we want to enhance the peak concentration. Why? Because we want GCMS to see the peak. If we don't do pre-concentration, then you won't see that much, just like this one. Okay, so that's about pipette tip microSPE. Then we go to microextraction by packed sorbent inside inside syringe. Okay, so what kind of syringe is this? I hope you still remember, this is the GC syringe. Okay, GC syringe is usually around 1 microliter to 10 microliter, right? While for liquid chromatography is usually from 10 microliter up to 50 microliter. So imagine that you can do extraction just inside the syringe, that we can take it and do GC right away. Isn't it fascinating? So I find it is really good because it saves the time a lot. And how they do it, okay? So okay, so you imagine the syringe, okay? In the hollow needle, they put sorbent inside there. How they put the sorbent inside there without the sorbent coming out? So there is a method we call as the polymerization. We polymerize the sorbent inside the syringe, and we put the sorbent on the wall of the syringe needle. Inside the needle, it will stick to the wall just like your capillary GC, right? The wall coated and also the monolithic coated. So when you draw in sample, you draw out sample, you do elution, they will be there as well. So that's how it was done. So this is the examples of application. Application to opium contaminated animal feeds, usually used in equestrian sports. So this is 300 microliter of horse urine sample. After doing lab in syringe microSPE, okay, we call it PET sorbent inside the needle itself, we can see morphine and codeine on top of the papaverine. Okay, noscapine is there as well, and it is actually analyzed at low ppm level. So that's the advantage of microSPE in